Going to approach the presentation differently this time. I'm going to start showing you the shortcut method, which is the most likely way they would show you in schools. I would then also do the same thing but using first principles to confirm why and how the shortcut method works. We are given 83 subtract a, or remove a, equals 8. Now what we want to do, the objective is to get a on its own but as a positive value equals some number on there on the right. This is subtract. If we take it over the other side, shortcut method, and do the reverse of the sign, it will work. So we need to move the a over to that side and change the sign, move the 8 over to that side and change the sign. So what we end up with here is 83, move the 8 across, there it is. If there's no sign, it's taken as positive, so it becomes negative, or remove 8. Take the a across, and instead of subtract, it becomes plus or positive. And then we just do our arithmetic with this part here, and that leaves us 75. Now by convention we normally put the a on the left, so a is equal to 75. Does this work? Well, let's substitute it back in. If we have here 83, remove, now instead of a we substitute in the value 75 equals 8. Is that true? Okay, well let's have a look. We got 83, remove 75, 5 and 10 is 5, 6, 7, 8. There you are, it is absolutely correct. It does work. You move it to the other side and you do the reverse sign. You reverse the action. Subtract is an action. Alright, first principles. We have wrong colour. (83) remove a equals 8. Now I'm going to put quite a bit of space in here. Here's the 83, there's the remove a, space, space equals 8. Now to move them to the other side we need to change that there, the a, to 0, because 83 remove nothing, doesn't change 83. Okay, so what I have to do is do the reverse of the action here. The action here says remove, so we put it back. That will then become 0, but because I put it back on the left, I have to put it back on the right, or add it to the right. If I've added it on the left, I have to add it on the right to make sure the equals remains true. Now I want to get rid of 8. Notice this, by the way, is now positive a. Want to remove 8. So I change that into 0. Okay, so what we do is we remove the 8 from the right. So that then becomes 0, and we remove the 8 from the left. What you do to the right, you do to the left. Okay, so this little lot here becomes 0. That and that becomes 0. So we end up with 83, that is 0, remove 8, equals, that becomes 0, so we're just left with positive A. So people don't bother to write the positive. Okay, so look, you compare this to that. It has become the same. This is what first principles do. Shortcut just remembers what happens in here. It is faster. It is quicker. In an exam, you don't have time to mess around. You use shortcut method. Let's do another shortcut method. Just for the sake of it, I'm going to use another letter. This time I'm going to use the letter B. And we're going to go for minus 15 equals 296. Yeah, just to be silly, shall we? Now we want B on its own, and B equals some number, some value, so we need to get rid of that. Okay, so there's your B, there's your equals, there's the 296. Take the 15 over to the other side, consider the number first, then look at the action, what you do. It is subtract. So over this side it is add. So we end up with B is equal to 6 and 5 is 11, carry 1, 9, 1 is 10, plus 1 is 11, carry 1, 2 plus 1 is 3, 3, 1, 1. Does that work? Let's have a look. We got 3, 1, 1, remove 15. And we get 5 from 10 leaves 5 plus 1 is 6. 2 from 8 is 9. Yep. Fast, isn't it? When you have just a few values like this, it is fast. In an exam, it is all about speed. But you also have to be correct. And it's a good idea to show you working out and be logical in your presentation so they can see what you have done, because you may get marks for method. You're always mark hunting in an exam.